Welcome all to the video lecture on the N Queen, a backtracking approach. Now, this will be the second in the series of the N Queen, the use of the backtracking approach. So let's start again, revisit quickly our N Queen problem. So this is our 8x8 chessboards with numbers 8 to 8 and 1 to 8. And now we have to place a queens. Total 8 queens we have to place such a way that no queen is going to attack any other queen. Yeah. Generally queen can go row, column or the diagonal. So if my queen is here, it can go to this particular row, this particular column and this particular diagonal. They can go. Okay. So now the initial approach that we have seen is that we have a total 8 for loops. For each row we have a 1 for loop and we are going to continue in that way. Now the problem with that approach is that, let's take one example to understand. Okay, just let me try. Let's take the problem with that approach. If we have a total 8 loops for each of the row, will there be a problem? Yes, of course, certain solutions that we are trying to recheck even though there is no anything that we have to check. Consider a first case. First 4, second queen here, third queen here, fourth queen here, fifth queen is here, the 6th, 7th and 8th. Now this solution before checking is generated in the previous approach where we have a total 8 for loops. Now why we want to check these solutions? We know that a queen is attacking any other queen that is come in the column also. So why we have to place any other queen in the same column where if some queen is already placed? We are already doing one queen at a row, so we don't have any problem of the row. The second approach here is the columns. Why we have to place other queen in the same column? So that is what the somewhat more, or you can say the more kind of unique compared to the previous where we are putting all the queens in the kind of similar rows or more than one queens in a similar column. We don't have to put any queens in the similar columns where already one queen is available. Therefore here we have to place a queen such a way that no two queens will be in the same column. So let me try to erase. So consider we have placed one queen here, maybe one queen here, one queen here. Clear? So we are not putting any queens in the same column. So you can see in this approach we are indirectly generating a permutations ultimately of 1 to 8, all the permutations of 1 to 8. Now the first approach that we have discussed, that will take n raised to n complexity because there are 8 times the for loops, in general n times the for loops. Now in this approach we only have to generate all the permutations, and if we have total n queens, then up to n numbers 1 to n, then we have n factorial permutations and only we have to check those n factorial permutations only. So compared to our initial naive backtracking approach, this backtracking approach is much faster. So that's what this video is telling you, that even within a backtracking, even though you're following a backtracking, you have to smartly try to use the backtracking approach. That will try to be very helpful in getting all your solutions in a minimum time, because backtracking will give you all the solutions, but even if you implement the backtracking badly, it will be far more complex. So that's why already backtracking is a complex thing, and if you even apply a bad approach in backtracking, it is, you can say, far more bad or the more complex. So that's why first backtracking approach n raised to n, a second approach here that we are trying to use, even though this is not our final answers, but here we are not putting any queens in the same column, any more than one queens in the same column. So ultimately we are reducing our solution set so that our final solution set will be derived from those sets. So we are ignoring those particular rearrangement of 1 to 8 where the one number will be repeated multiple times. So that's what this solution is about. A smart movies generate all the permutations, even though still it is a backtracking approach, because we are here generating all the possible solutions. Generally in greedy and divide and conquer, or you can say the dynamic programming, it will give you the one of the optimal solutions, while in backtracking you can design in a way that will give you all possible optimal solutions. And there is a way of insight in this particular solutions that also we will try to explore in our next video series. We will tell you how this all optimal solutions will be utilized to find a good method in a given algorithm. So look at this particular solutions. This is all the permutations now we are only using, and we will check out whether this permutation is our solution satisfying the criteria of all the rows, columns. That is by default they are satisfying rows and columns. Only thing we have to now check is the diagonal. So here we can say this particular queen is attacking here in this diagonal, even this queen is attacking in this diagonal. That is what they are doing. So that's why this is not our optimal solution. This is not the one answer of the 8 queen problem. Okay. But yes, we are making some moves. We are making less complex algorithms in backtracking. So firstly we start with this thing where all are 1 1 1. Well, we don't want any number to be duplicated, so that's why we will use all the permutations. Look at the particular algorithm that we will start with the generate the initial permutations, and if we are not complete all the permutations and we are not getting the solutions, we will go with the next permutations. And if we are getting our answer, this particular solutions is one of our solutions, then we are going to print. Otherwise we will say fine, we don't have any solutions. So if we want to generate all the solutions, then we have to modify this code. We have to remove these conditions from here, and within the while loop we have to put that if these solutions will be our solutions, then we are going to print. In that case, this particular backtracking algorithm will give you all the solutions of 8 queen problems. That is what backtracking does. Good. Now this particular little piece of code will tell you how to generate the next permutations. You just simply have a ti and tj. So this t array, you will rechange the numbers and you will get the next permutations. Exchange the two numbers and then you will get the next permutation, so on and so on. So this particular piece of code will try to generate you all possible permutations of the given algorithms. So now again it will start with all the permutations. So first it will put the first queen here. Now in the first permutations we cannot put the second queen here. We have to put the queen here, then we have to put the third queen here. 1 2 3 4 5 6 7 8. That is what the first permutations. Okay, yes, it is not our answers. Okay, it is not our answers. So in next thing it will draw backtrack from here. It will try to do it. It will try to put it here. This particular it will try to put, so this way here only this will be my try to check whether this will be my solutions, yet not, because still this particular things will be not satisfying our answers. So but yet we have designed a less complex compared to the first approach to a backtracking way, and still this will give us all possible solutions in our answers. So this is what we have, one of the solutions. So this is here the permutations is one of the permutations. Now we can check that none of the queen is more than one queen is in the same column. So that's what the key insight of this particular approach, that we have to generate all the permutations, and from that permutations we will utilize. So here the answer will be, this is my 4, this is my 6, this will be 3, this will be 8, this will be 2, this will be 5, this will be 1, and this will be 6. So this will be my solution, one of the solution vector. Okay, and you can see that none of the number is repeated. That is what make the key insights. Clear? Okay, that is the references. If you want to go in the detail of this thing, you can refer the syllabus, you can refer the PTL MIT videos as well as any learned material on the permutations also. You can refer the slides of how to generate a permutations, and there is an efficient algorithm that you can try to use for the generating all permutations and check whether this permutation will be answered or not. Thank you for watching this video.